Hi everyone, and welcome to the fifth video on the National 5 Chemistry Unit 2 topic. Today we're going to talk about naming and drawing branched alkanes. So far we've spoken about the prefixes that tell us how many carbons are in chains. We've spoken about the alkanes themselves and how to draw, name, and how many carbons and things are in those as well. But now we're going to have a look at slightly more complicated alkanes, because everything we've had so far has had our carbons in chains. Now in chains I mean going from one to the other without any hydrogen. So I'm going to put down 6 carbons here. If I just had hydrogens all around the side, then this would just be hexane. But I'm going to put in another carbon here. Now we spoke last time about isomers and the fact that you could take a carbon from the end and swap it to where a hydrogen should go to make an isomer, so something that has the same molecular formula but a different structural formula. Now if I put in all of my hydrogens now, and you can see the full structural formula for this compound, we're going to talk about how we go about naming something like this. So all my hydrogens in, making sure all of my carbons have their valencies fulfilled, so they've all got 4 bonds. That's what we have here. So the first step for naming, the first rule for naming, is to select the longest chain. So we select the longest chain of carbon atoms. And when I mean the longest chain, I'm meaning we can go from one to the other, essentially without taking your pen off of the page. So my options would be to start from here and go all the way along to the end, or I could start my branch and go this way. And we want to see which one's longer. So if I start from here, I would have 1, 2, 3, 4, 5, 6 carbons in my chain. If I started from here, I would have 1, 2, 3, 4, 5. That is my shortest chain. So the chain that I'm looking for, and I'll just put a ring around that, is this one here. This is the longest possible chain that I can go from one to the other without lifting my pen off the page of carbon atoms. Okay. So then my second step is to number the carbon atoms. From the side nearest the branch. Now what do I mean by that? Any carbon that's coming off of my main chain in my alkane is called a branch. And I'm going to number the carbons from the side closest to this branch. So I could either go carbon number 1, 2, 3, 4, 5, and 6. Or I could go carbons 1, 2, 3, 4, 5, and 6. I want this branch to be on the lowest number, so I'm going to number from this side, making this carbon carbon number 3. 1, 2, 3, 4, 5, 6. Because if I numbered from here, this would be carbon 4, which would have the higher value. Okay. I then want to identify the type of branch. So I want to identify the type of branch. There's 1 carbon in this branch, and we know the prefix for 1 is meth. If I have a branch, I add YL to the end of that prefix, and that means I have a methyl branch. That is the type of branch that I have, because there is 1 carbon in my branch. Now I can put this all together and start thinking about this. So my parent alkane, my longest chain, is 1, 2, 3, 4, 5, 6, all single bonds between them. So my parent alkane would be hexane. Carbon number 3 has a methyl branch, so I have 3-methyl hexane. And that is how you name these. You can have ones that have more than 1 branch in it as well. And we're going to use this one as an example. 1, 2, 3, 4 carbons with a branch here and a branch there. all my hydrogens getting filled in. To fulfill the valency of all of the carbon atoms. Again, step 1, select the longest chain of carbon atoms. For this one here, I'm going to go 1, 2, 3, and 4. I'm numbering from this side because it doesn't actually matter if I number from here because my branches are on the 2 middle carbons, but they're the same number either way. So I've numbered 1, 2, 3, and 4. I'm going to identify the type of branch. Now this one's slightly more difficult because here is one branch, but here's a second branch coming off of the chain. So let's have a think. My parent alkane has 4 carbons, so that makes it butane. I have 2 branches on carbons 2 and 3. So I would write 2, 3 dash. So commas separate numbers and then dashes separate numbers to words. And this is a methyl and this is a methyl. So I'm going to write this, methyl. But I'll have a wee gap here. And the reason I've left a wee gap here is because I have 2 branches. I need to know in the name that there is more than one branch. And so to do that, I add the prefix di. So 2,3-dimethylbutane. And that tells me there is a branch on carbon 2, there is a branch on carbon 3, there are 2 methyl branches on the butane chain. That's how we name these branched alkanes. And it's important to note that if carbon 2, see this branch here, if this was on here and both of my branches were on the same carbon, I would have to write number 2 twice to be very, very clear that both branches were on carbon 2. So if I had a carbon up here and this was a branch, it would go 2,2-dimethylbutane. I would need to have that number in twice, and that's quite important. Another rule I just want to put in here, it's quite important I'd say, is you can't have a branch on carbon 1. Now that is really important because let's think about pentane. 1 carbon, 2 carbons, 3, 4, and 5. Okay. My hydrogen's all getting written in again. By the time you finish this unit, you will be sick of writing C's and H's, making sure all of them are capital, remember. Let's have a look at this though. Now, this looks like there is a branch on this carbon. Let's look at my molecular model again. We looked at this last time, and remember I said about this could twist. And we can twist the chain in different ways, and that could make us think that we either have our nice straight chain, or in some ways, branches. That could look like this has a straight chain and then comes down and there's a branch here. Yeah, this could also look like it if you did it this way around. This is just this chain twisted because I can go from this carbon and I can go round and go round 5 carbons without lifting my pen off of the page. So that is pentane. It's the same as this, it's just twisted. So your chain can go down around the corner. It does not need to be in a straight line. It could also go 1, 2, 3, 4, like that, with all my hydrogens on. Doesn't matter, I can still, without taking my pen off the page, go this way round. Okay, really important fact to note. Now if I just take that away for now, the next thing, once you are happy with being able to actually name them, we have to do this in reverse. We have to be able to draw something from the full structural formula. So I have 3,4-dimethyl hexane. as an example. Step 1, draw the carbons for hexane. 2, 3, 4, 5, and 6, because remember hex means 6. There's my chain for hexane. Okay, so I've done this part of my name. Dimethyl. So I just said 2 seconds ago that di means I have 2 of the same branch, so dimethyl. The methyl branch has 1 carbon in it. Where will I find those? On carbons 3 and 4. Now just to make things easier, you can number from the left. Sometimes you will have them numbered from this side. So just be careful of that, but when you're drawing it, you have control of being able to number from this side or this side. I would always number from left to right. So if I have carbon 1, 2, 3, 4. Now it doesn't matter if one is up and one is down. Remember this twisting that we were speaking about? This could twist and both those carbons could be on the same side. It's the same thing. So 3 and 4, dimethyl. Let's fill in our hydrogens. So all my bonds are in there. Every carbon there has 4 bonds. And then we go around making sure all of these definitely look like capital H's. I'm definitely guilty of going too fast writing them, and sometimes they look like squiggles more than anything, but make sure they are clear. And there we go. Now let's check it. Think of our rules that we were using. Let's do this in reverse. Longest chain, start from here. If I find this to be my longest chain, 1, 2, 3, 4, 5, 6. I could number from either side because these are in the middle 2 carbons, but if I numbered 1, 2, 3, 4, 5, and 6. Carbon 3 has a methyl, carbon 4 has a methyl, so that's 3, 4, dimethyl hexane. And that is how you draw from the name. And that's everything so far. We've covered everything we need to know about the alkanes themselves.